Okay, now this question on the surface, for the first part at least, can seem fairly awkward, and it's just understanding how the presence of H plus, acid or H3O plus, and OH minus affects what we have present here. Obviously we've got chloride ions, we have silver ions, we also have present, we have CrO4 2 minus, which is the indicator, and that's the chromate ion. And in this question really you need to just know some chemistry which you may not have been taught, and that is that the chromate ion kind of has an equilibrium thing going with Cr2O7 dichromate, and I don't know if that's completely balanced, but this isn't really important. This is just to illustrate the fact that if we have too much acid present, which is the H plus, it pushes the equilibrium over there, and we have in effect dichromate. So the indicator would basically, we would have less CrO4 2 minus, so the indicator would actually change, would get used up. So if we have a low pH, in effect we end up with dichromate, and we don't want dichromate. This will not work with dichromate. So that's really the first part, and if you didn't know that, you really couldn't get started on this question for the first part anyway. So what happens if there's too much base present? What if there's too much hydroxide? Well, kind of big clue there is we've got silver there. If you remember from qualitative chemistry, there are a lot of precipitates that can form with hydroxide. Silver ion one's a little bit different, and it forms silver oxide. Okay, if you remember that equation, Okay, so if you recall, if you add hydroxide to silver, you get a precipitate of silver oxide, that kind of brown precipitate, and water forming. So that's obviously a solid. Now I don't require to do the equation for that, but that's the problem with having too much hydroxide. So you really just need to address those two situations, the one where it's too acidic with the dichromate, and the one here with it's too basic. Okay, and that's that question there.